Okay, in Math 30-2 in topic 7.4 today we're going to look at solving exponential equations using logarithms. Let's get started. So in example 1, solving a compound interest problem using logarithms. Bailey has $3,215 in savings. If the interest rate is 2.4% compounded annually, how long will it take her to get to $5,000? Well, we're going to use our compound interest formula, which is A equals P times 1 plus I to the power of N. A is our amount that we want to get to, that's 5,000. P is our principal, the amount that we currently have, which is $3,215. 1 plus the interest rate would be 1 plus, and then the 2.4% in decimal form, so it would be 1 plus 0.024. All of that to the power of n. Now we can simplify our equation and solve for n using logarithms. We can say that this is going to be 5,000 equals 3,215 times 1.024 to the power of n. Now we can divide both sides by 3,215, canceling the 3,215. Then we can take the log of both sides. And when we take the log of both sides, you can bring the exponent n down and put it in front from our logarithm, our power rule for logs. And now we can divide both sides by the log of 1.024. And using our calculators, you can plug all that in and you'll find that n is equal to 18.620. It's going to take 19 years for her balance to be $5,000 if the interest rate is 2.4% compounded annually. Example 2. Selecting a strategy to solve an exponential equation. We're going to round our answer to 3 decimal places. In our first example, solve 3 to the power of x minus 1 equals 20. We're going to take the log of both sides. The log of 3 to the power of x minus 1 equals the log of 20. Now I can take the x minus 1 down and put it in front of log 3. And that's still going to equal log 20. At this point, I'm going to divide both sides by the log of 3. That'll give me x minus 1 is equal to log 20 divided by log 3. Now I can just add 1 to both sides to solve for x. Plugging that into my calculator, I'm going to get a value of about 3.727 rounded to 3 decimal places. Next problem, number 3. Using logs to solve a half-life problem. 500 grams of radioactive radon-222 is sent to a lab. 19 days later, they found they only had 13.417 grams remaining. Determine the half-life using logarithms. So what's happening here is that the radioactive radon is just going to disintegrate over that period of time. So we want to figure out what's its half-life. How long does it take for half of it to disappear? The half-life equation is A equals A0 times 1/2 to the power of T over H. A is going to be the amount of substance remaining. A to the 0 is going to be the initial amount of substance that we started with. T is time, and H is the time at which only half of the substance remains. That's what we're going to be looking for. So the amount of substance remaining is 13.47. The amount of substance initially, of course, was 500 grams. Our time, we're told, is 19 days. And H is what we're trying to find. So when we plug all that into our equation, you're going to get 13 13.417 equals 500 times 1/2 to the power of 19 over h. Well, let's clean this up the best we can. I can divide both sides by 500, and then I can take the log of both sides. So I got the log of 1/2 times 19 over h to the power of 19 over h. Now I can bring down the 19 over h to the front, and continuing, I'm going to get the log of 13.417 divided by 500 has to equal 19 over h times the log of 1/2. If you divide both sides by the log of 1/2, you're going to end up with 19 over h. At this point, you can cross multiply or simplify first and then cross multiply, and you're going to end up with h being 19 divided by 5.219, or 3.639. This tells us that the half-life of radon 222 is 3.6 days. To verify graphically, you can plug into your graph, make y1 the left side of your equation, and you can make y2 the right side of your equation. And then where these two graphs are going to intersect, when x is 19, y is 13.417, it's showing you that 19 days is how long it's going to take to produce 13.417 grams of radon 222. Next, we're going to solve exponential equations with different bases. Let's solve 2 to the power of x minus 1 equals 3 to the power of x plus 1. This is why we're using logs. First thing I'm going to do, round to 3 decimal places, is take the log of both sides. Log of 2 to the power of x minus 1 is equal to the log of 3 to the power of x plus 1. Now I can bring the exponent down and put it in front. I'm going to get x minus 1 times the log of 2 equals x plus 1 times the log of 3. Now I'm going to expand it. I'm going to get x times log 2 minus 1 times log 2 equals x times log 3 plus 1 times log 3. Just distributing it out. Now what I'm going to do is I'm going to gather the x log 3 and x log 2 on the left side. So I'm going to get x log 2 minus x log 3 equals, I'm going to bring the add log 2 to the other side, so I'm going to get log 2 plus log 3. Now I can factor the x out of the left side. So if I did that, I'm going to get x times log 2 minus log 3 equals log 2 plus log 3. Then I can divide both sides by log 2 minus log 3, and canceling and evaluating this and plugging that in my calculator, I'm going to get a value of negative 4.419. Using a change of base strategy to evaluate a log. If we had to evaluate log base 2 of 100 to 3 decimal places, x is going to be the log base 2 of 100, so that means that 2 to the power of x has to be 100. Now the log of both sides, log of 2 to the power of x is going to be the log of 100. That means x times the log of 2 is going to be the log of 100. Divide both sides by log of 2, and x is going to be the log of 100 divided by the log of 2, which is going to be 6.643. Your assignment is going to be page 455, numbers 1 to 6, 12, and 15.